So the videos which are there on the website, I explained everything in detail. So from the introduction all the way to the last part of circular motion. And also I went further to solve the questions. The throw sheet for 1010 I solved is even there. For 1015, because I don't have, that's the reason I didn't manage, I didn't solve. So if you're going to send for me, meaning by the end of this week I'm going to solve. Then again, the past papers from 20 should be 2015 to 2022, to 2023 exam past papers I solved from this topic, circular motion. So you can check them out from the website and you'll be able to access. Okay, unless if you're having questions, if you have questions before we start, can we start? Can we start? Can we start? This is what I was telling you last time. You don't respond, that's a problem. So it will be hard for me to know whether I should proceed or not.
Yes, sir, start.
So you'll be asking questions where you are not clear, and then we see how we can. Okay, so circular motion. Basically, when we're talking about circular motion, we're talking about a motion around the circle. Okay, when an object is moving around the circle, we call that rotational motion or circular motion. So you may think of a car moving around the roundabout. That is one of the examples of circular motion. You might be rotating, anything, just that is circular motion anyway. So under circular motion, the first thing we're going to talk about is, if you understand, if you know linear motion, where we were talking about the v final is equal to the v initial plus a times t. Then we were also talking about the distance is equal to v initial times t plus half a t squared. Then we were also talking about this v final squared is equal to v initial squared plus 2ad. So this is what we call translational motion. Translational motion. Translational motion is the same as linear motion. So I can also say this is the linear motion. Then there is also what we call rotational motion. So when an object is moving around the circle, the same formulas which we are talking about under rotation, translational motion, which is linear motion, when we're talking about this is what we call linear velocity. Okay, so this is linear velocity, this is also linear velocity, this is linear acceleration, this is linear displacement. Does that make sense? So this a is what we call linear acceleration, then v, it is linear velocity, then what else, d is linear displacement, like that. That is when we're talking about linear motion. Then when we come back to rotational motion, there is what we call the same acceleration, but it's going to be angular acceleration. The velocity is going to be angular velocity. The displacement is going to be angular displacement. Okay, so angular velocity is represented by alpha, that is omega, sorry. Then acceleration is represented by alpha, displacement is represented by theta. These are the only changes which we're going to be talking about here. So the same formula which we have here, but here I'm going to say W final is equal to omega initial plus alpha times t. That is the formula now when it comes for rotational motion, meaning the angular velocity final is equal to the initial angular velocity plus angular acceleration times time. Then here I said where there is d you put theta, so it will be like this. Then here is the same thing. I just put this. So most of the times these are the formula we're going to be working around with. Does that make sense? So that's the relationship between rotational motion and translational motion. Is that okay?
Yes, sir.
Okay. So another thing which we have to know is there are also some formulas which I want you to know by heart. If you have been watching my videos, I explained where these formulas are coming from, but here, since this is just a tutorial, I'm going just to, but you're not supposed to know where they're coming from. But if you are interested to know where they're coming from, I'll I'll advise you to go and watch the videos if you didn't manage to watch the videos. But even if you didn't manage to watch the videos, it's okay. You'll be able still to know what we are doing. So again, one thing we should know is that the distance, which is d, should I say just the angular displacement? So the angular or the linear displacement, it is also given by theta times r. Then when it comes for the velocity, I'll say v is given by this. When it comes for the acceleration, I'll say a is given by that. These formulas, there is no exam or there is no test without you using these formulas. These three, they are very, very important. Okay, so for example, from what I've given you here, it is very important also for us to understand when we're talking about angular velocity. So there is what we call revolution, radian. What else do we use? Okay, for now let's just use this. So in one revolution, if this is a circle, in one revolution there is a 2 pi rad. There is 2 pi radian. At the same time, there is 360 degrees. So this theta, it can be either in revolution, in rad, or in degrees. So when you want to convert from revolution to degrees, you know that one revolution is equal to 360 degrees. But in most cases, when we're talking about circular motion, it's either we're going to be leaving our answers in revolution or in rad. Okay, so the SI units for theta, it is basically revolution. You can say revolution or rad, or even theta, or even degrees. And then the angular velocity, it is now is either revolution per second or revolution or rad per second. Okay, then the angular acceleration is now is going to be revolution per second squared or rad per second squared. Does that make sense? I'm giving you the overview before we start solving this question.
Also, I've got a question, sir.
Please ask.
So, like, 2 pi radian is the same as 2 pi?
Okay, so 2 pi, this radian is more like the unit, not more like, but it's the unit. So in short, we are saying in one revolution there is 2 pi rad. So rad is just the unit, but the number is 2 pi. You get it?
Yes, sir, I've understood. But again, I'm a little bit confused on those formulas on the right hand side where there is angle W
Yes, yes.
and pi.
Um, but did you understand when I said this is the velocity, this is the displacement, this is the acceleration?
Yes, sir.
Yeah, so what I did was those formulas from linear motion where we are saying v final is equal to v initial plus at. Since I know that when it comes for rotational motion, velocity, it is this w, but since it is final, then I'll just put final. But again, this I'll just put this. Then acceleration, this one, it is angular acceleration, which is alpha. Then t is just t. That is this formula. Okay. Then that other formula, d is equal to v initial times t plus half acceleration t squared. Since I know that d is alpha or is theta when it comes for rotational motion, then velocity is just this. Then I'll put just this times t, then plus half acceleration is alpha, then t squared. So I'm just replacing, like, for this is the rotational equivalent to what? It is the equivalent of the theta is the same as d, but on that when we're using theta, then we're talking about circular motion. When I'm using d, I'm talking about linear motion. When I'm using omega, we're talking about rotational motion. Rotational motion is the same as circular motion. Still behind?
No, sir, I've understood.
Okay. So like I've said, these formulas, the three formulas which I've just put here, these ones. Guys, these formulas are very, very important. There is no test without using these formulas. It's not possible. That's what you should know. So if you are writing an exam and then you come out of the exam, you have even chosen the question for rotational motion. You have not used these formulas. Then you consider yourself to say, but I think I've made a mistake. The chances that you cannot use these formulas, I think, is 0.5, but 99.5% that you are supposed to use these formulas in an exam or in a test question which is going to come. Is that okay? So let's try to solve this question. So this question is saying a belt runs on a wheel of radius 44 centimeters. During the time the wheel takes to coast uniformly to rest from an initial speed of 1.6 revolution per second. Okay? 29.5 meters of belt length passes over the wheel. Find the deceleration of the wheel and the number of revolution it turns while stopping. Since we have understood, I'm going to get rid of everything here, all the formulas. The first thing when it comes for this, I can advise you guys just to correct the data. The formula is going to come after the data. So the first thing you're going to write, what do we know? We have been given the radius. So now that radius, it is in centimeters. I have to convert it into meters. So I'll say 44 divided by 100, which is 0.44 meters. Done. Next, what else do we know? We can also clearly say that we have been told that the displacement, which is d, is 29.5 meters. I've skipped velocity because I want us first to understand again the question. We are saying the wheel takes to coast uniformly to rest from an initial speed of 1.6 revolution per second. So I have got my angular velocity, which is, we have been told that initial, which is 1.6 revolution per second. Okay. Now, what is the final angular velocity from the question?
It's zero, sir.
Why?
Since you've been told that find the deceleration, and
Mhm.
again the question says it takes to course uniformly to rest. So if there was deceleration, which means the car was stopping.
Exactly. So you can think of that if they're talking about acceleration, meaning most of the cases, if they are not mentioning anything about the final velocity is always zero. But if they're going to give you the final velocity, you're going to use it. If we are, sometimes they can also, they can't even mention to say find the deceleration. Uh-huh. In fact, these guys, this question was wrong. Let me now tell you. Do you know that? Oh no, it was not wrong. It was not wrong. But let me just emphasize something. Do you know that if I tell you that acceleration is equal to negative 5 meters per second squared, then another one tells you to say the acceleration is 5 meters per second squared. Do you know that this is the same thing? So if you're finding acceleration, then you find that is negative. That is deceleration. So you can't say deceleration. If you say, like in this case, then we find the answer. We say deceleration is equal to negative 5 meters per second squared. No. So the negative itself represents deceleration. So again, you are saying, it's like you are saying repeat again. Repeat and again, they're the same thing. So you are repeating again, which is not true. You get my point, eh? So that's why when finding the answer here down, they had to put acceleration because there is negative. You understand my point, right? So in some cases, in some other books, they're not going to, or in maybe other questions, they're not going to tell you to say find the acceleration. They just say find the acceleration of the wheel. But you know that when it was coming to stop, then you are finding the acceleration. Okay. Now, here they're not mentioning anything about the time. Definitely, you can't use any formula which involves time. The only formula I can use right now is the third one, this one. The final angular velocity is equal to the initial angular velocity plus 2 alpha times theta. But we have everything except theta. That's where now those two more formulas I gave you, they are coming in. I have the radius, I have the displacement. You remember the formulas I gave you? I want to find the theta.
Sir, sorry to take you back, but didn't you say that
Mm-mm, I didn't say that. If I say that, then I made a mistake. What I meant was d is the displacement in meters. Theta is, so d is the linear displacement. Theta is angular displacement. So when we're talking about rotational motion, the theta represent distance. That's what I meant. You get my point, eh?
Yes, sir.
Yes. So theta represent distance, but it is in land. So it can be in land or revolution. Okay. So now I gave you those formulas. You remember those formulas? I wrote them here. That's why I said you can't run away from those three formulas. Even if you don't know where they're coming from, just know them by heart. So I gave you these formulas, guys. I said d is given by theta times r. And our goal is to find theta. I will divide it by r. So theta will be equal to d divided by r. I have everything now. So d is 29.5. R is 0.44. Now here they're not mentioning anything whether I should put my answer in revolution per second squared or in rad per second. So you follow what you have been given in the question. Okay? You follow what you have been given in the question. So in this case, the theta which I'm going to find here, let me make things clear there. The theta which I'm going to find there, we should take note to say it's going to be in what? If I may ask you, the theta which we are going to find is going to be in what? Okay, it's going to be in lad. The reason why it's going to be in lad is in most cases when we are trying to find the theta, and then this theta we are trying to find here, it is what? Should I say we're going to find this in rad? No, we're not going to find. Okay, it's going to be in revolution because the question here is just direct in revolution. Is it making sense? Okay, let's do this. When you are converting, let's do this. When you're converting, when you're using these formulas, when you're using these formulas, then also what another formula is that? Or here I'm supposed to put v. Sorry. I even forgot as well. I'm supposed to put v is equal to this, then a is equal to that. So when I'm using these formulas, the SI units will always be in rad per second. So when you find the answer, just know that the answer is going to be in rad. Then that's when now you're going to convert. Have I made myself clear? So
Yes, sir.
when you're using these formulas, the your units are supposed to be either in rad per second or in meters per second. If it's distance, it's supposed to be in meters. If it is radius, it's supposed to be in meters. Okay? Then, if it is velocity, it's supposed to be in meters per second. If it is angular velocity, a rad per second. If it is angular acceleration, a rad per second squared. Okay? Have I made myself clear? That would mean to say the answer which I'm going to find here is going to be in what? If you have gotten what I've said there. Hmm? So I'm getting my theta to be 67.01. So this answer is going to be in what? According to what I've said. Hey, guys,
Ingredients.
it's going to be in lad. So this is now in lad. So what I'm going to do now is I'm going to go ahead and use my formula to find the answer. But don't you think that this guy which we have here is either we change this one, wait, it's either we are supposed to change this one to we are supposed to change this one to revolution, because I'm trying to find my, it's either now that is up to me. If I want my answer to be in rad per second squared, it's either then I'm going to change this one to be in rad per second. If I want my answer to be in revolution per second squared, then I'm supposed to change this one to revolution. You get my point, right?
So, sir, what's the relationship between rad and revolution?
The relationship is that in one revolution we have got 2 pi rad. That's the relationship, sir.
Okay.
Yes. So that's why it is very easy, as long as you know that in one revolution there is 2 pi rad. Even converting, I can even give an example here. The same 67.01, it is rad. Okay? And I'm trying to convert this into revolution. So it will be times, I'll say, in one revolution, how many rad do we have? We have got 2 pi rad. So the rad and rad will cancel. This and that will cancel. And I will remain with 67.01 divided by 2 pi, which is going to give me 10. So it's giving me 10.66, which I can just say 10.7. Now that is now in revolution. You have seen, right? So that revolution is the one I'm going to put it in this formula, because I've got revolution per second, because I need the answer to be in revolution per second squared. Is it making sense? That would mean to say the second question, which is saying, and find the number of revolution it turns while stopping. When you are talking about the number of revolution, we are talking about theta, and we have already found theta. Theta, it is 10.7 revolution or 67.01 rad, which is the answer, which is here. So when any question, as long as they're talking about revolution, find the revolution. You are finding the theta. That is revolution. Find the number of revolution it turns. That is the theta. The moment you come up with theta, that is the revolution, the number of revolution. So sometimes they would say find the number of revolution in lads. When you find it in revolution in rev, then you have to convert it to lad. If they say find the number of revolution, if they don't specify, you can either leave it in lad or in rev. It's fine. No one is going to penalize you. We can go ahead and solve now this one, right? So since I'm going to use theta to be 10.7 revolution, let's see what we're going to have. So the alpha, the final is 0, the initial is 1.6, but I have to square it, plus 2, the alpha we don't know, the theta is now 10.7. So if I shift this to the other side, it's going to be like this. If I do times 2 there, it will be 2 times 10.7, which is 21.4. Then again, this is going to be 1.6 squared, that is 2.56. It is 21.4. Divide both sides by 21.4, even here 21.4. So my alpha will be equal to, if I do 2.56 divided by 21.4, I'll get 0.1196. I round it off, negative 0.12. So that should be in revolution per second. That is the answer they found here. Who is behind? And the information which I've given you right now it can help you to solve actually a lot of questions. There are some questions from past papers I'm going to send you, and I want you to solve them. You send the answers today. The information which I've given you right now, guys, for just this question, you can solve a lot of questions. I'm going to give you the questions which came last year. Believe me, it's going to take about maybe 10 minutes for you just to finish solving them from what I've given you, as long as you have understood.
So, sir, you mean that acceleration under linear motion, we know that it is meters per second squared,
Yes,
but under circular motion, it is revolution per second.
squared. Or I'm supposed to put squared here. It's supposed to be squared. So it's revolution per second squared or rad per second squared. Now, how do you know that I'm supposed to leave my answer in rad per second squared or in revolution per second squared if you have not been told to put the answer in either revolution per second squared or in rad per second squared? Sometimes they are going to ask you to say, leave your answer in rad per second squared or in revolution per second squared. But what if they don't mention? If they don't mention, you have to follow the velocity which you have been given in the question. If the velocity is in revolution per second, then even your final answer has to be in revolution per second squared. Does that make sense?
Yes, sir.
Okay, thank you. So can I move to the next part of circular motion? I think I've exhausted almost everything here. Hmm? Okay. So if you're not going to manage to solve the questions which I'm going to send to you, you please, you can just inbox me or you can just ask in the group and then I'll be able to help you. Okay. From what I've explained here, there are some questions I want you guys to solve, the ones I'm going to send in the group. So the next thing which I want us to focus on is this one. Now, we are saying that circular motion, an object is when an object is moving around the circle. Now, when an object is moving around the circle, okay, let's say this is the roundabout. For an object to move on the roundabout or around the roundabout, there is what we call the friction. Without friction, an object can't move around the circle. If it's a car, there's supposed to be friction. Now, that friction is directed toward the center. Before I explain this question, allow me to explain about centripetal force and centripetal acceleration. I'm going to start with this. This is the circle. The force that is directed toward the center is what we call centripetal force. At the same time, you're going to have also centripetal acceleration. Okay? So centripetal acceleration is given by v squared divided by r. I'm trying to come up with a very solid formula, guys. Centripetal acceleration is given by v squared over r. Okay? Now, what of centripetal force? But in general, what is force? So the force is given by mass times acceleration. But in this case, we're talking about centripetal force. Then centripetal force is going to be equal to the mass times the centripetal acceleration. But what is centripetal acceleration? Centripetal acceleration is given by v squared over r. So I'm going to say it is given by m, then where there is a, which is centripetal acceleration, I'll put v squared over r. So the general formula for centripetal force is mv squared over r. This is the formula for centripetal force. Does that make sense? So centripetal acceleration, same principle. The mass has to be in kgs, radius has to be in meters, the velocity has to be in v, or it has to be in meters per second square. Oh, it has to be in meters per second, sorry. Then in some cases where you have not been given, now this is the case now, the case where you have not been given the velocity, then they give you this angular velocity. That's why I say those formulas are very important. So you can use this formula, v is equal to this, and make and plug in the values. You're going to be given the radius, plug in the values to find the v. When you find the v, that's when now you come here and put it in there. Or if you're dealing with the angular centripetal acceleration, then you plug in there and find the centripetal acceleration. Does that make sense? Now, centripetal force can be represented by many things. If an object is rotating, okay, let's say around the roundabout, so there is friction there. Friction will always be directed toward the center for that object to move. Now, in that case, friction force is going to act as centripetal force. Therefore, we can say that friction force, since it's the same as centripetal force, then I will equate it equal to centripetal force. But according to Newton's laws of motion, what is friction force? Friction force is mu times the normal force. But again, what is the normal force? Normal force is mg, meaning that friction force can be mu times mg. Then let me go back here. I'll say normal force, the friction force, I'm going to replace it with this, mu times mg is equal to, what is centripetal force? Centripetal force is mv squared divided by r. From here, in most cases, you're not going to be given the mass. Since you have got mass both sides, you can cancel them. So you remain with mu g is equal to v squared divided by r. This formula, guys, is very, very important. You can make anything as a subject of formula. This is mu and not mass. Let's not complicate things here. This is mu. Mu, then g. You can make anything as a subject of formula. You can make mu as a subject of formula. You can make v as a subject of formula. You can make r as a subject of formula. Let's go back to our question. A carton of eggs sits on the horizontal seat of the car as the car rounds a 26 meters radius bend at 16.5 meters per second. What minimum coefficient of friction must exist between the carton and the seat if the egg are not to slip? The moment you hear the question, they're talking about a car rounds, then what should come in your mind, the free body diagram, is the one I've given you here. Okay, so from here I'm going to restart, since there I was just giving you the general idea behind the centripetal force. From this question here, I can clearly see that I'm going to come up with my free body diagram. This is my roundabout. So here is the carton of, I'll say this is the car, because the carton of the eggs were inside the car. So the friction force will be directed there. Since it was moving in that manner, you can say that the velocity, that is, you say v is equal to 16.5 meters per second. Now you start. The friction force will be equal to the centripetal force. then you know that friction force is equal to mu times the normal force. But the normal force is mg. So you replace this with the mu times mg is equal to what is centripetal force? Centripetal force is mv squared divided by r. Replace that one with what you have here. But you know that we don't have mass in this case, so the mass can cancel out. So mu times g is equal to v squared divided by r. Our goal is to find the mu value. So what are we going to do? I can cross multiply. It is just the same as dividing this side by v or g, sorry, even here by g. Mu value will be equal to v squared over r divided by g, if maybe you want to make things simple. So you have v squared divided by r times 1 over g. Then you end up having the mu value to be v squared divided by rg. This formula is very important. But if they ask this question, don't just come and put this formula. No, it has to come from there. Okay? Now, from here, we want to find the answer for this question. From what we have done, let's plug in the values. So we have mu is equal to, the v is 16.5. Now it has to be squared. I divide this by what is r? R is 26. Mind you, the mu value, we are saying that it is always less than 1. Okay? But I have to explain something here. The mu value, according to what we learned under Newton's laws of motion, we said it should be always less than 1. So now, what is g? G is always 9.8. Unless if you have been told that g is 9.81, that's when you are going to use that. But if they don't mention anything, use 9.8. So 16.5 squared divided by open brackets 26 times 9.8. I close the brackets. So I'm getting 1.068, which is the same as mu to be 1.07, which is the answer they found here. Now, I want you to ask me, why is it that the mu value is greater than 1? We are saying that the mu value should be always less than 1. Let's go back to Newton's laws of motion. The friction force is equal to mu times the normal force. If I'm to make the mu as a subject of formula, I'll divide both sides by normal force, normal force. So this is equal to that. In all the cases, you are going to find that the normal force is always greater than the friction force. In all the cases, let me say 98%. So 98%, you are going to discover that the friction force will always be less than the normal force, or the normal force will always be greater than the friction force. But in some cases, that is 2% now. In a case where the friction force is greater than the normal force, then the coefficient of friction is going to be greater than 1. That is the case we should have right now. So right now, the normal force is less, or is greater than the static friction. Have I made myself clear? Hmm? Have I made myself clear, guys? The reason why in this case the normal force or the coefficient of friction is greater than 1. So the normal force is less than, the static friction is greater than the normal force, or you can say the normal force is less than the friction. Please ask.
Sir, the time when you're explaining why the coefficient friction was more than one, the network was kind of tripping. I didn't hear you right, please.
Okay, so I said in a case where the the normal force is less than than the friction force, then the coefficient of friction is going to be greater than 1. In other words, we can say if the friction force, in this case we're talking about static friction, so let me just use static friction. So let's say if the friction force is greater than the normal force, then definitely the coefficient of friction is going to be greater than 1. But that is rarely, like in this case we have now found it. But in most cases, the coefficient of friction is always less than 1. Okay? Does that make sense? So you know what we have done, Upper. So we have exhausted a lot of things. A lot of things, guys. A lot of things. I can show you something. Let me show you the questions which you are going to answer. It's very important for you guys. Okay? It's very important. Okay. So last time when we were talking about circular motion, we were talking about we mentioned to say circular motion can be represented by many things actually. So what is happening is let's say you have a rope and then there is an object. Now you are trying to spin. Okay, you're trying to spin. So what is happening is this is the rope. The force supported by the rope is what we call the tension force. Okay, so what is happening is this. Now if you are you are spinning something at a very high speed, this is what is going to happen. Okay, so this is going to be straight. I like demonstrating this. I use maybe centripetal force is going to be just straight to the circle. In that case, then you say centripetal force is equal to mass times v squared over r. That is if you are spinning this object at a very high speed. So this rope is going to be straight. So in this case, the force supported by the rope is what we call the tension force. So in this case, then we are going to say that the tension force is equal to the centripetal force. So we know that centripetal force is mv squared divided by r. So you can use this formula again to find the tension force. So the tension force and the centripetal force, they are going in the same direction. You understand? Hmm?
Yes, sir.
Now, in a case where you are spinning this object at a very low speed, okay? So what is going to happen? What is going to happen is this. Um, this is an object. It will come like this. It will be like that. Then the circle will come here. I might start from here, like that. So you realize that you are going to have This is the tension force, quite okay. But this tension force is going to have the x component and the y component. So the theta will be formed, will be here. There is an angle which is going to be formed. So this is the tx, this is meaning is ty. Using Sohcahtoa, what can we see? We can clearly see that since this object is in free fall, meaning there is mg, the gravity which was pulling this guy down, like that. Initially, this object is moving in x direction. Sorry, yes, in x direction. In y direction, there is no movement. So the force in y direction and in x direction, they are going to cancel out. Therefore, we can say that the summation of all the forces in y direction, when we add them, they should give us 0. What forces do we have in y? We have got ty pointing upward, then mg is pointing downward. That's why I'm going to put minus, is equal to 0. Of which I can say, using, if I go back to vectors, ty is t sine theta minus mg is equal to 0. Shift mg to the other side, t sine theta is equal to mg. I'll leave it here. Who is behind on how I've gotten this gamma formula? You can't tell me that you are not, you don't have questions. That's a lie, guys. It's a lie. Who can explain to me why I've said that the summation of all the forces will be equal to 0? Who? Who can explain? Hmm? Okay. Now, let's talk about in x direction. So in x direction, we know that centripetal force, as long as there's the force moving toward the center, therefore we'll say that centripetal force, the summation of forces in x direction, the only force we have in x direction is what? The tension force, which is Tx. But in this case, this Tx is moving in the same direction as the centripetal force. So therefore, I'm going to say the centripetal force will be equal to Tx. So Tx is T sine cos T cos theta should be equal to Fc is mv squared divided by r. Who is behind on how I've gotten this? I'm trying to reach at a certain point where we're going to have one formula. Hello.
Yes.
We are good to go.
Yes.
Okay, perfect. If we are good to go,
Sir, I have a question.
please ask.
Yeah, sir, I have a question.
Please ask. Ask,
I
ask,
have a
ask.
question.
Ask.
My question is where we place the angle there, sir. How do we know that the angle is supposed to be below or above the tension when we're solving? If we've been given a question around the diagram like that, certain questions where the angle is placed above the tension point. So when do we know when to place the angle?
Okay. When do you know where to press the angle? Okay, it depends with the question. For example, Let me read this question and then I'm going to answer that question. So the question is, a 450 grams ball at the end of the chord, is that word I've failed to pronounce it, in an almost horizontal circle of radius 1.525 meters. Its tangential speed in the circle is 8.5 meters per second. Do not neglect the weight of the ball. The string cannot move perfectly horizontally. So, what must be the tension? Then another question is, what angle does the chord make with the horizontal? How do you understand when we say um with the horizontal, or maybe when we are talking about forces? Oh, sorry, when we're talking about vectors, just get it from that perspective.
The horizontal is like the x-axis.
The
So
x-axis.
yes.
Yes. So, from what you have said, where do you think we are supposed to put the theta? Initially, what is happening is they're just trying to do this. Initially, you know that if this was moving at a very high speed, this tension force, this line here, initially is supposed to be just straight like that. That's what I said, right? But in this case, since now it has been raised at an angle, so the angle can never be here. This is 90 already. It can never be here. The angle has to be here. This is the angle we are trying to find. Okay? So even when we reach at a banking curve, there's a situation where we're going to be putting an angle maybe here, but I'm going to explain the reason why we're going to be putting an angle there. I don't know if I've made myself clear.
Yes, you have. Thank you.
Okay. So what we have now here, we have two things. I'm going to come up with two things. I want us to come up with a formula which is going to help us to find the tension force and also the angle theta. Okay? So, if this is my radius, we have been given the radius. The radius is 1.25 meters. What else have we been given? The mass. If I convert that mass, what are we going to have? If I convert that mass, it should be 0.45, right?
Yes, sir.
Then the speed, we have been told that the velocity is 8.5 meters per second. Perfect. So I'm going to make here this formula. I'm going to make t as a subject of formula. What do I mean? What I mean is this. Can I get rid of this a bit? I'll come back. What I mean is, now, yeah, sometimes you can ask, why do we always make, when you are trying to make, we have got two unknown variables, and then you are trying to make something as a subject of formula. We always make the one having cos as a subject of formula. Do you know the reason? Okay, here, how can you know that I need to make this t as a subject of formula? The reason why I'm going to get for cos, because when I divide sine divided by cos, it's going to give me tan. That's the reason why in most cases you find that when you have got cos and sine, you make the one for cos as a subject of formula, so that you end up having, so like in this case, I'm going to divide both sides by cos theta. Not so? Am I doing the correct thing? Yes. So I'll have t is equal to mv squared divided by cos theta times r. That is the same as where there is t here, you put mv squared over cos theta r. So I'll say mv squared over cos theta r. Also there is what? Yes, well there is t. Then I'll say is equal to mg. What do we say? Come on. Here I'm supposed to say sine, right? I'm replacing just t. So it will be sine theta times mv squared divided by cos theta times r. But you know that sine times cos is tan. So we'll end up having tan theta is equal to, or tan theta times m v squared divided by r is equal to mg. At this point, even if I have mass, but anyway, I'll just cancel the mass. So if I cross multiply, I'll end up having this. I'll end up having I'll end up having tan theta is equal to v square. Oh, it should be v squared. Then what? What else?
over R.
Over r. If I do g times r, it's going to be rg, right? So
Yes.
if I want to find theta, it will be rg divided by v squared. What does it mean? I don't even, okay. So this means that I'll have theta is equal to tan inverse of rg divided by v squared. Can that be correct? Definitely it has to. The radius is 1.25 times 9.8, 12.25. Shift tan 12.25 divided by 8.5. Now we square it, we close the brackets. So you can confirm, those having calculators, we are trying to find theta, and here according to what I've punched here, I'm getting 9.6229 degrees, which is the answer which they have given us here. When you find theta, tension is not going to be hard for you. I believe so. Should we go ahead and find the tension, or maybe we have people who have questions? Yes, 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 yes.
Don't tell me when I punch, their answer is different.
No,
I don't know, maybe it means
v,
not punching properly.
v has to be squared.
Oh, okay, okay, okay.
You have seen, ka?
Yes.
Yes. It's okay now. We can continue.
Yes, it's okay with me.
Okay. So if you have the theta, remember we had to make theta as a subject of formula somewhere here. We're trying to find the tension force. There are so many ways of getting that. I think if you watched my videos, I solved this one already. I used a different method. So you choose. That's why attending again is okay. You choose either to use this one or the one I used in the video. So you see which one is easy for you. So I'll say T is equal to the mass. I'm going to plug in here because I want to find T. The mass is 0.45 times the V is the V is 8.5 squared divided by 1.25. So what would be the tension force? 0.45 times 8.5 squared divided by 1.25, 26.01. 26.01 is my answer, which is approximately 26 just. Now, um, no, we have forgotten cos theta, right? Down there.
Yes, you didn't put. Mm.
Yes, so I'm supposed to do times cos theta, cos which is 9.62. Let's see. So I'll just say, I'll put them in brackets. 0. What is 1.25 cos 9.62? It's 1.232. So 1.23, 1.32, sorry, 1.232, 1.232. So I'm going to say 0.45 times 1.5 squared divided by 1.2. I said 1.2 what? 3, eh?
You said 1.23.
Okay, I'm now getting 1.23. So T is equal to 26.4 newtons. If I give you a question here based on this part, can you babaika?
Let's try, sir. Give us listen.
After all, even if I give you, you don't even uncarnish, you don't even send the answers. That's a problem.
Sense, Kaili.
Guys. Okay. What's the time? Wait, I need also to. I wanted to teach you conical pendulum, but looking at the time, but I think I can manage to teach you this. There's a part I want to teach. There's this question. I really like this question. Person held stationary. Yeah, this one. I like this question. Let's try to solve it. I've got a paper I'm going to give you. We see. Especially when I teach you this one. There's a question I'm going to send. Don't worry. Okay, so this question Let me before I even read the question. So what is happening here is this: there's a concept under circular motion where when someone is in the drum, okay, let's just assume that this is a drum. So this drum, what is happening is that there is a person. So a person, I'm going to put it just like here. Allow me to present this as a person. So as this person is trying to slip like from the top here going down, what is happening, guys, is this. What is happening here is this. If you have got a surface here, this is the surface. If there is an object on top of the surface, the force perpendicular to the surface, this is the surface. Now the force perpendicular to the surface is what we call the normal force. So even here, you are going to discover that we have the normal force, which is going to we have the normal force, which is just a minute. Okay, so you have the normal force, which is going to be perpendicular to the surface, and the surface is this one. So the normal force would be here. But for you to move from top there, if there is no friction, you just slip from the top there direct here down. But because of friction, you realize that the friction will always try to balance up with what the mg, which will be down. So if I might get this part, allow me to get just this part. So then the person is here. So what we're going to have here is the normal force, which is here. Then the friction force will be directed in that manner. Then down here is going to be mg, because it's going to be the friction, oh, the gravity is pulling you down. But because of friction, then you just be rotating. Now you'll be moving around the circle in the drum. So what is happening here is that as long as there is a force which is directed toward the center, that force can be equated equal to the centripetal force. So we say the summation of all the forces in y direction, since this object is not moving in y direction, when I add all the forces in y direction, I should get 0. Then the force which I have right now in y direction, I've got the friction force pointing upward is going to carry positive, minus mg pointing downward is equal to 0. Friction force is mu times the normal force is equal to, I can shift mg to the other side, which is going to give me like that. But let me hold on here. One thing I should also remember is that when the force is directed toward the center, like the way this force is, then we can conclude that the centripetal force can be equated, or that force can be equated equal to centripetal force. That's what I said. So the normal force in this case is going to be equal to the centripetal force. But we clearly know that centripetal force is mv squared over r. Therefore, in this case, the normal force will be equal to mv squared over r. So it's the one I'm going to replace it there. So I'll say mu mv squared over r is equal to mg. But in this case, I can clearly see that I've got mass both sides. I can cancel mass. Okay, then I'll remain with mu v squared divided by r is equal to g. We can cross multiply to get rid of the fraction. Or it's the same as just doing times r over v squared. I don't know which one is okay for you. So if I cross multiply, I'll end up having this. Then rg divided by v squared divided by v squared. So v squared and v squared will cancel. I'll end up having this. I'll end up having mu is equal to rg divided by v squared. In this case, if you have been given the velocity but in angular velocity, you can convert that velocity to, or you know that last time I told you that v is given by this. If you want, you can replace this by that, but it has to be squared, or you can find first the answer. But since this is in revolution per second, so I need to change to rad per second. Okay, so 0.6 revolution per 1 second times, I know that in one revolution there is 2 pi rad, so this and that will cancel. 0.6 times 2 pi, 37, is it 3 or 37? My calculator, 3.7, right? Or we can say 3.8 rad per second. Then I'm going to replace, now from this formula I'm going to replace v with wr, so it will be w squared r squared. I can cancel r on top and r1 down here, so mu will be equal to g divided by this. Plug in the values. G is 9.8, w 3.8, but squared. R is where is it? 2.8. So
Sir,
yes,
then R at 2.5, you said 2.8.
no, it is 2.5. Is this one? Have you seen?
Yes, I have.
Okay, so 3.8 squared times 2.5. So I'm getting my answer to be 2 point or 0.27. Only that I had to round it off here. If this was exactly like the way it was in just 3 decimal places, it was supposed to give me exactly as 0.28, but 2.7 is fine. Even this one, you can round it off, it's going to be 0.3. It's making sense, right?
Yes.
Okay, so I can check. Okay, let me send the questions.
Sir, I've got a question before you proceed.
Please ask.
In what conditions or cases is the coefficient friction supposed to be greater than none?
When the normal force is greater than the friction force. Sorry. When the normal force is less than the friction force. That's the only condition.
Okay, thank you.
Sure. Another question.